This video is for Part C of Lesson 2.4, so this is the final section for factoring and solving polynomials. We've already learned how to factor lots of different polynomials using different methods, and we're going to review that a little bit here, and then at the very end we're actually going to solve. You may remember that solving means that we're taking something and we're setting it equal to 0 so that we can find out an actual real number value that x would be equal to. So when you're trying to solve a polynomial by factoring, after you factor it completely, remember completely, you have to keep going until there's nothing left to factor, then you must set each of the parentheses equal to 0 and solve for the values of x using algebra. So let's go ahead and do this example and you'll see exactly how this works. So set one side of the equation equal to 0. So we have to get this over to the left side, and we want to make sure that we're going to write it in standard form. So if I move that over to the left, it's going to be a negative 18x to the third. So my standard form equation is going to be 3x to the fifth, since 5 is bigger than 3, and then negative 18x to the third plus 15x equals 0. All right, and because we're setting it equal to 0, that means that we're going to find out an actual value for x. We're not just going to factor. We're going to take it one step further and actually find out what x is equal to. And now we can factor the polynomial completely using the greatest common factor, or we can do factors of c sum to b, or we can use difference of two squares, or grouping, or whatever method is necessary for us to get it to, all the way broken down in our factored form. So because I see that this, and these terms all have a 3x in them, meaning that the 3x is going to be a greatest common factor, I can pull the 3x out and then just leave inside what is left. So I'm going to have x to the fourth minus 6x squared plus 5. That's going to be equal to 0. Now I could stop here if whatever's in here is completely factored. That trinomial is not completely factored. So now I'm going to look for two numbers that multiply to 5 but sum to negative 6. And those two numbers are negative 5 and negative 1. So now I'm going to have x squared minus 5. And notice that I'm using x squared because the first exponent in that polynomial is a 4. So x squared minus 5 and x squared minus 1. That's equal to 0. And then I could stop if I was completely done. However, I see a difference of two squares. So now I'm going to have to factor that. So I'm going to end up with x plus 1 and x minus 1, okay, equals 0. So now I've taken out my greatest common factor. That was the first step of my factoring. Then I went ahead and factored the information that was inside the first polynomial. Then I noticed that there was this difference of squares. So I have this as my final answer, and what I have to do now in step 3 is set every single thing equal to 0. So I have to say 3x equals 0. I have to say x squared minus 5 equals 0, x plus 1 equals 0, and x minus 1 equals 0. So every part of my factored form has to be set equal to 0. And if I divide this by 3, x is equal to 0. So I'm going to come up with multiple answers for 0. And if I add 5 and add 5, then x squared equals 5, and therefore x equals plus or minus the square root of 5, because I'm going to take the square root of both sides, of course. And then if I subtract 1 and subtract 1, x is going to equal negative 1. And then, of course, if I add 1 to both sides for my last one, x is going to equal positive 1. So I literally have all of these as my solutions. So don't be surprised if you end up with multiple solutions to a problem. All right, let's take a look at example 1. Always try to factor out a greatest common factor first, although you do want to make sure that everything is on one side of the equation before you get started. So my equation should be 2x to the fourth plus 2x to the third minus 24x squared equals 0. Okay, and I'm looking for a greatest common factor now, and it looks like There's a 2 in all of these, as well as an x squared, because there's my x squared right there. So 2x squared is going to be my greatest common factor. What's left is x squared in that first term, plus x minus 12. Now, I have to find a couple of numbers that multiply to negative 12, but sum to positive x, or positive 1, I guess. So I would be going with the 4 and the 3, and we would be saying that it's going to be positive 4, so x plus 4 and x minus 3, that would give us a positive 1 if we added them together. And then what I have to do is I have to set each one of these. So I'm going to set 2x squared equal to 0, because I'm done factoring after this step here. And then x plus 4 equals 0, and x minus 3 equals 0. So we're looking at those three. And then for this first one, divide by 2, x squared is going to equal 0, therefore x is 0. And subtract 4, so x is going to be equal to negative 4, and that's a negative 4. And then if I add 3 here, x is going to be equal to 3. So I have 3 solutions for that problem. All right. And I will do this one as well over to the right. It looks like we can do the square, right? This is a difference of squares. So I would have x squared plus 1 and x squared minus 1 equals 0. But this is not completely factored all the way. So I'm going to rewrite this. I'm going to have x squared plus 1. That's the first binomial. But then x plus 1 and x minus 1 is the factored form of our difference of squares here. So now I have to set this equal. So it's going to be x squared. If I move that over to the other side, is going to be negative 1. That actually is going to be a not real solution, because when I take the square root of that, remember this ends up being I. All right, so we were only looking for real solutions here, so this solution doesn't work. But I might have some other solutions that are real, so let's go ahead and do this one. This would be x equals negative 1. Whoops, negative 1. And this one would be x equals 1. So I do have 2 real solutions, even though I did not have all real solutions. I at least have those 2. Okay. On the back side, we have a few more practice problems to look at. One thing I want to make sure that you remember is to put everything to one side. So this needs to be moved to the right-hand side, and we want to make sure that we're putting our work in standard form. So what I'll have is I'll have x to the 4th plus 7x squared plus 6 equals 0. Notice that now my first term is positive because I moved it over to the right-hand side. So I'm looking for 2 numbers that multiply to 6 but sum to 7. And even though my exponent here is a 4, I can still do that. Remember, we can just cut it in half. So I'm going to end up with x squared plus 6 and x squared plus 1. And the reason it's 6 and 1 is because those 2 numbers multiply to 6 but sum to 7. And that's going to equal 0. Now, if I set each of these binomials equal to 0, so it's going to be x squared plus 6 equals 0. I'm going to subtract 6 on both sides. X squared equals negative 6. If I take the square root, remember that's going to be a negative value, which is going to end up being an imaginary number, so that is not a real solution. Okay, so anytime you have a negative number under that square root, it's going to be not real, and we're only looking for real solutions, okay, not imaginary ones. So I'm going to do this one over here. X squared equals negative 1, and again we're going to have a negative number under the square root symbol, so another one that has no real solutions. Okay, that one's not real. So basically that's your answer. X doesn't have any real solutions for either of these binomials, or for the equation itself. All right, let's take a look at problem E. We're going to be we're going to have you guys do the problems over to the right. So all of these problems, D, F, and H, those will be the ones that you practice on your own. And if you watch this video a couple times, you'll definitely have the knack of how to do the solution. You already are pretty good at factoring. All right, so we want to get everything to one side in problem E. We're going to end up with x cubed plus x squared plus x plus 1. This looks familiar. Now, because we already know how to do this one, we're going to do factor by grouping. We are going to take our factored parts and set them equal to 0. That's the only change, really. So I'm going to pull out my greatest common factor, and I'm going to remember that x plus 1 is going to be the same over here, right? Because we have to have the same binomial. Since there's nothing else to pull out, I'm going to put a 1 there because 1 times x is x, and 1 times 1 is 1. So remember that what you're doing is you're taking the information, this greatest common factor, and putting those in their own binomial, and then x plus 1 is going to go in its own binomial. So there we go. We have our factors of this polynomial, and then I can go ahead and take the square root, well, set them equal to 0 first. So x squared plus 1 equals 0. That's going to end up with another negative number there, and if I take the square root of both sides, what is that? That's not real. Okay, so there's one solution that's not real. And then if I set this one, x plus 1 equal to 0, subtract 1, x is equal to negative 1. So we do have one real solution for that one, but anytime, like I said, if there's a negative number under the square root symbol, that means you're going to have a not real or imaginary answer. So we'll just write not real. Okay, so this is the last problem I'm going to do, and then I'm going to let you finish up with the problems over to the right. Using all of your factoring methods, the only change here again is setting those factors equal to 0. So I want to get all of this over to the left-hand side. So my new equation, when I move that stuff over there, is going to be negative 10x plus 40 equals 0. Remember, when you move things over, it changes the sign. So what do I have? Well, I don't see any greatest common factors here, but I do see that I can split this right down the middle, and I can end up factoring the first two and the last two. So I'm going to say, well, 2x squared. Actually, I'm going to go ahead and take a negative 2x squared out. That's going to leave me with an x and a negative 4. And so over here, I'm going to end up with x minus 4 also, because remember, the binomial has to be the same on both sides. And it looks like I'm going to have a negative 10 in the front here, since negative 10 times x is negative 10x. All right, so now I'm going to take my greatest common factor here and here, put that in its own binomial, and then my x minus 4 is my other binomial, and those are equal to 0. So there's my factored form. Then my next step is going to be setting this equal to 0. And negative 2x squared equals positive 10. Divide by negative 2. That's going to be x squared equals negative 5. And again, this is going to be a not real solution because I'm going to have that negative number there. So not real. All right, there's one not real. And then this one, of course, is going to be x equals 4. So I do have one real solution and one solution that's not real. So there's a couple changes to what we're doing. We're actually seeing that when we're solving, we're coming up with not real solutions. Those are called imaginary solutions because the square root of negative 1 is I. All right, and then also that we're just going ahead and solving, setting everything equal to 0. So every time you get your factors, make sure you set them to equal to 0 and solve. So you're going to tell me what x is equal to. And of course, I'll take some questions in class.